Hi and welcome back to the Core Learning channel. Today I'm going to be going through the June 2023 Maths GCSE Higher Tier Paper 1, and this is the non-calculator paper. I'm going to be going through each question and showing the methods I use to solve each of these questions. If you haven't already, please hit that like button and subscribe to our channel. This really helps us grow and reach more people, so your support really does help. Plus, if enough of you subscribe, I might actually get paid to do this. With that, let's jump into our questions.
So, question 1, we have 0.7 times 0.5. Well, this is just 0.35. Another way you can think about this is that this is 1 over 10 times 7 times 1 over 10 times 5. So if you do 7 times 5, that's 35, and then 1 over 10 times 1 over 10. So this becomes 1 over 100 times 35, which equals 35 over 100, which is just 0.35. So that's just an alternative way of doing this. It's a 1-mark question. Hopefully you should know how to do that. For part B, I should call that part A. For part B, we have working out 5 over 6 divided by 3. Let me just move that up. So, using some rules we know about multiplying and dividing fractions, this is equivalent to 5 over 6 times 1 over 3. So, after the divide sign, we can just flip whatever's there and then change the sign to a multiplication. So this becomes a lot easier. So this is just 5 times 1 over 6 times 3, which is 5 over 18. And again, for part C, we have 27 divided by 0.6. So this is the same as 27 divided by 6 over 10, and is therefore the same as 27 times 10 over 6. And this gives us 270 over 6. We can just divide top and bottom by 2, and we get 135 over 3. Can we do any more to that? Yes, we can actually. We can divide by 3 over 3, and that equals 45. Yeah, just equals 45. Moving on. So question 2, we have solve 2x is less than 26. So here all we're going to do is we just divide both sides by 2, and the 2's cancel out on this side, so we get that x is less than 13. Question 3, here we have work out the value of 3 over 2 squared, and we want to represent this as a mixed number. So let's just write this out. So this is 3 over 2 times 3 over 2, which is 9 over 4. And so the way we think of this is if one unit is 4 over 4, so 4 over 4 equals 1, then to get 9 over 4, we have 4 over 4 plus 4 over 4. So let me just, this equals 1, this equals 1, this equals 1, and then plus 1 over 4, and this gives us 9 over 4, so we'd write this as, well, 4 over 4 plus 4 over 4 is 2, and then we just have this quarter left on the end, so it's 2 and a quarter. So moving on to question 4, and we are told that EBD is equal to 5 times ABE. We are told that DBC is equal to 3 times ABE, and we also know that ABE plus EBD plus DBC, it lies on a straight line, so this must equal 180 degrees. And using these 3 bits of information, we should be able to work out the size of angle EBD. How are we going to do this? Well, what we're going to do is we're going to substitute in our value of ABE into here. So we know that EBD equals 5 times ABE, and we know that DBC is 3 times ABE. And now we have an equation which has one unknown, which means we can now solve this. So we have ABE plus 5 ABE plus 3 ABE equals 180 degrees. So that gives us 9 ABE equals 180 degrees. So let's divide both sides by 9, cancel out on here, and we get that ABE equals 180 divided by 9, which is 20, and it's in degrees. So moving on to question 5, we're told that two prime numbers are multiplied together. The answer is an even number between 50 and 60. If we remember, a prime number is a number which can only be divided by 1 and itself. So probably the easiest way to do this, let's just list out some prime numbers. So 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. Let's just stop there. Let's see if with that current batch we can meet the conditions of this question. So it's got to be an even number between 50 and 60. We've got to multiply two of these together. So let's just look at it now. Well, actually I can see 2 here. So if we multiply 2 by 29, that gives us 58. 58 is between 50 and 60, and it is an even number. So 2 and 29 works here. Moving on to question 6. And we're told Andrew and Bruce share some money in the ratio 5 to 6. I'm not going to read all this out, but I'm just going to start writing. So we've got the ratio A to B. So I'm just using A, B, and C for Andrew, Bruce, and Carl. So A to B is 5 to 6. So we're told that Bruce gets £96. So let's rewrite this ratio using this information. So A to 96 equals 5 to 6. So let's just compare those for a second. So if we have A to 96 and 5 to 6, the question then becomes, if the transformation from here to here is something, then we have to apply the same transformation from here to here. So to get from 6 to 96, I believe we have to multiply 6 by 16, and then we can do the same on this other side, multiply by 16, and that tells us that Andrew's amount is 16 times 5, which is 80. It's £80. So we now know that Andrew has £80. We know that Bruce has £96. And then the last thing we're told is that Carl has a quarter of Andrew's money. So we have a quarter times £80. And he's also given 2/3 of Bruce's money. 2/3 times £96. So working this out, well, a quarter of 80 is £20. And then 2/3 of 96, well, if we divide 96 by 3, then we get 32. 32 times 2 is 64. So this is £64. Adding these together, we find out that Carl has £84. Question 7, we're told to work out 2 to the power of A times 3 times 5 squared equals 600, and we have to work out the value of A. So let's just simplify this. So we have 2 to the power of A times 5 squared is 25 times 3 is 75, which equals 600. So let's just divide both sides by 75, and these cancel out. So we get 2 to the power of A equals 600 divided by 75, which is 8. So 2 to the power of A equals 8, and therefore we know, if we can just work this out, we can say that 2 times 2 times 2 equals 8. So this is equivalent to 2 cubed, and therefore A is 3, just to be clear. So moving on to question 8, and we're told to expand and simplify fully. 5 times 3x plus 4 minus 2x minus 1. So this equals 15x plus 20 minus 2x. Just be careful, we have a minus and a minus, so this goes to a plus, so plus 2. And then we just collect our like terms, so 15x minus 2x is 13x, and then plus 20 plus 2 is plus 22. For question 9, we're given this graph Erica has sketched of y equals 1 over x, and we're asked to make 2 different criticisms of her sketch. Now, the first thing that I notice here is that the y-axis is crossed. This should not be the case. As x approaches 0, y becomes infinitely large, but it never actually touches the y-axis. It never is 0. So the first criticism I would have here is the graph shouldn't touch the y-axis. The second problem with the graph is that on the left-hand side over here, when x is less than 0, then y should only take on negative values. So if we were to think about it, if we took x as, let's say, minus 0.5, then y is going to be equal to minus 2. So 1 over any minus value is a minus value. So the graph actually should look something like this. So the second criticism here is that for x, and in fact that's wrong, not x greater, for x less than 0, y should be negative. Moving on to question 10, and we are told that Sunita is X years old, Beth is 1 year younger than Sunita, Joel is double Sunita's age, and the mean of their ages is 5. How old is Joel? Right, so what do we know here? Let's call Sunita S, and if we call Sunita S, then we know that Beth, so which I'm just going to call B, is S minus 1, and we're going to call Joel equal to double Sunita's age, so 2S. So we're told the mean of their ages is equal to 5, so what this means is Beth plus Joel plus Sunita over 3 is equal to 5. And if we sub in our values of B and J in terms of S, we have S minus 1 plus 2S plus S over 3 equals 5. And we can times both sides by 3. So we cancel here and we times by 3, which equals 15. We should move this up. So if we simplify this, we have 3s plus s is 4s minus 1 equals 15. And therefore 4s, if we add 1 to both sides, is equal to 16, and therefore s equals 16 over 4, which is 4. And we want to know how old Joel is. Remember, that's what we're actually searching for. So Joel, if we remember, is twice Sunita's age. So 2 times 4 is equal to 8. Joel is 8. Question 11. And we're given a Venn diagram. And we're told it represents 100 items. So we have event A, event B. And we're asked for part A to work out the probability. And what this means is the probability of A and B. So the probability that A happens and that B happens. Well, in this case, you can see here from the Venn diagram that A and B is this 13. So 13 events happen in A and B, and this is out of 100 total items. So 13 over 100, which we're going to write as 0.13. So moving on to part B, we're asked to work out the probability of not A, so A apostrophe, that means the probability of not A. Well, if we look here, where does A occur? A occurs, so 28 events occur solely in A, and then 13 events occur in A and B, so these all count towards the same total. So the probability of not A is 100 minus, I'm going to call it N, so this is the number of events in A over the total number of events, which is 100. So the number of events in A is 28 plus 13. So the probability of not A is 100 minus 28 plus 13 over 100. Well, this is 59 over 100, so it's going to be 0.59. And move on to part C. So for part C, we want to work out the probability of A, and this is A or B. So that's what this U shape looks like. So the probability of A or B is going to be everything that's contained within those circles. So you could do it as 28 plus 13 plus 48 out of 100. I'm just going to do it as 100 minus the probability that it's not A or B. So 100 minus 11, so we can see 11, which is outside of the circles, over 100, and that is 89 over 100, which is 0.89. So 12a, and we're told that a times 10 to the power of n is a number in standard form, and we want to complete the inequality for the value of a. Well, when we write standard form, A is generally written as a number between 1 and 10. So the answer here should be that A is equal to or greater than 1 and less than 10. And for part B, we are told that B times 10 to the power of n is equal to 7,200. Well, if we're to take our advice from the previous question, we know that B should be a value between 1 and 10. So in this case, if we've got 7,200, let's say that it's 7.2, and then 7.2 times what is 7,200? Well, it's going to be 1,000. So 7.2 times 1,000 equals 7,200. So now we need to convert this value. So we've got our first part. So this is going to be our B. And then we need to write this as 10 to the power of n. So basically, what is n? So 10 to the n equals 1,000. Well, in this case, it's going to be 3, isn't it? Because 10 times 10 times 10 is 1,000. So 10 cubed equals 1,000. And in fact, if you read the question carefully, which I almost didn't, we want to work out b times 10 to the minus n. So in this case, it's going to be 7.2 times 10 to the minus 3. So moving on to question 13, and we're given a number machine which inputs x, multiplies by a, adds b, and the output is y. So let's write this out. So we have a times x plus b equals y. And we want to show that if we increase the input by 2, the output increases by 2a. Okay, well, let's write this out as a, and then remember x is our input, so we add 2 to this, plus b, and then what does this equal? Well, let's expand out the bracket. So we have ax plus 2a plus b, and then we can rearrange this as ax plus b plus 2a. Well, we can see here, we know ax plus b is equal to y, which is the output, and therefore this 2a means that when we increase the input by 2, then the final output, which I'm just going to call y prime, is y plus 2a. So moving on to part B, and we're told that f of x equals kx squared, and Kai says that f of 6 over f of 2 is equal to f of 3 because 6 over 2 equals 3. Is he correct? Well, let's see. So let's just write this out. So we have f of x equals kx squared, and let's just work this out. So what is f of 6? Well, this is going to be k times 6 squared, which is 36k. F of 3, pardon me, f of 2 even, is equal to k times 2 squared, which is equal to 4k, and therefore f of 6 over f of 2 equals 36k over 4k. So k's just cancel, and this is 9. So the question is, what is f of 3? Well, f of 3 is equal to k times 3 squared, which is 9k. Now, obviously these are the two values we're comparing. These aren't equal because f of 3 is 9k, not 9. So f of 6 over f of 2 does not equal f of 3. So moving on to question 14, and we're given this number line here, and they are 5, 8, and we've got a blank, and then we've got 13, 19, blank, 25, 28, blank, 34, and then another blank. And what we're told is that the lower quartile, median, upper quartile, and highest value are missing. So given that they're in numerical order, let's just label these. So this is going to be our lower quartile, this is going to be our median, this is going to be our upper quartile, and obviously this is going to be the highest value, which I'm just going to call max. So what are we told? We're told that for the median, which let's just call that m, so we've got m equals 2 times the lower quartile. We're told that the upper quartile is equal to 2.5 times the lower quartile. And we're told that the range equals 2 times the interquartile range, which is just the difference between the upper and lower quartiles. Now, the easiest way to go about this is that we know the lower quartile must be between 8 and 13. But even more than that, we know that the upper quartile is 2.5 times the lower quartile. What this means is, given that every number on this list has to be a whole number, the lower quartile must be an even number, because an odd number times 2.5 is going to produce a decimal number. So that means that the lower quartile can only be 10 or 12. So if we were to take the lower quartile as 10, this would suggest that the median is 20. Now the median must be between 19 and 25, so 10 is still in contention for the lower quartile. And then the upper quartile would equal 2.5 times 10, which is 25. Now the upper quartile has to be between 28 and 34. So this means that 10 is not an acceptable value. So let's just check then. Presumably 12 must be the correct value. Well, if it's 12, then the median is 2 times 12, which is 24. That is in the acceptable range for the median. And the upper quartile is going to be 2.5 times 12, which is going to be 30. And this, again, is between 28 and 34, so this is acceptable for the upper quartile. So this must mean that the value of the lower quartile is in fact 12. And from this, we know that the median is 24, the upper quartile is 30, and we're told that the range is 2 times the interquartile range. Well, if that's the case, then the range is equal to 2 times upper quartile minus lower quartile, which is equal to 2 times 30 minus 12, which is 2 times 18, which is 36. Now the range is the difference between the highest and the lowest value, isn't it? So if we say that range equals max minus min, then max equals range plus min. Well, we've just said that the range is 36, and we know that the minimum value on this list is 5. Therefore, the max value is 41. So let's just go back and fill those values in. So we have 12, we have 20, we have 30, and we have 41. So moving on to question 15, and we have a trapezium here and a series of statements which we need to assess as true, maybe true, or not true. Let's start with the first one. Triangles AXB and CXD are similar. So we're looking here at these two, and I'll just undo those. So these are the two triangles we're looking at, and what does it mean by similar? Well, for similar, it should share the same angles, the proportion, i.e. the length of the sides will just be different. So is this true? Well, yes, it is true for the following reason. If we call this angle here A, for example, and this angle here B, because A to C is on a straight line, we know A plus B equals 180 degrees. But we also know that B to D is also a straight line. So we know that the angle here must also be A, and this angle here must also be B. So if we know that angle A is consistent between the triangles AXB and CXD, do we know that the other two angles are also the same? Well, because we know A to B and D to C are parallel lines, in this case, we do know that it must be the same. So in this case, we can tick this one as true. So the second statement is that triangles AXD, so this is this triangle here, and BXC are congruent. Well, first things first, what do we mean by congruent? Congruent means they're the same. It means they share the same angles and they have the same length at the sides. So is this going to be true? Using what we said in the previous question, if I call this angle Z, I know that this angle is also Z. Do I know that the other two angles in both triangles are equal? Well, let's just draw out a triangle. We'll call this angle Z, so the pen works. Call this angle Z. Now my question to you, is there any way, given that we know that these two sides are not equal, we're told that all four sides are different lengths, so we know these two sides aren't equal, is there any way to have an equal length side to what we have here at the bottom and still have exactly the same angles, which let's call them x and y, just for simplicity. So x and y. Is there any way we can have the same length where x and y are the same? The answer is no. If we keep x and y constant, then all we can do is increase or decrease the length. That's the only way. So in this case, triangles AXD and BXC are not congruent. Moving on to the next statement, and we're asked if angle ADB equals angle BDC. So let's just highlight the two angles in question. So here, that is angle BDC, and then let's choose a different color. Let's choose blue. So let's just highlight those. So in blue, we have angle ADB, and in red, we have angle BDC. Are they the same? Well, what we can do here is, using the fact, I'll just label this. So this is line AB, this is line DC. If we have a straight line that intersects there, we know that this angle here is going to be the same as this angle here. And this means what we can say is that the angle here, so ABD, this angle here is the same. So both angles in red here are the same angle. So what does that tell us? Well, if the angle in blue is to be the same as the angle in red, then the only way this could be true is if these two lengths were equal. That's the only way that can be true. But we know that those lengths aren't equal. So we know that the angle in blue cannot be equal to the angle in red. So this is not true. And finally, our last statement is that the area of triangle ABC equals the area of triangle ABD. So let's just highlight these two triangles. So we've got ABC, and let's go for blue, and we've got BDC, no, ABD, which is here. So these are our two triangles, and we're saying just area of triangle ABC equals the area of triangle ABD. Well, we know for a triangle, the area is given by the base, and then area is a half B times H. So we can see that for the base here, they share the base. So in this equation down here, B is going to be constant. So the question is H constant? Well, if we draw out one of the triangles, so if we draw it out like that, we know that for both, the height is going to be the same, because the height is the distance between these two parallel lines. The triangles both finish on the same straight line. So the area is going to be the same because the only two variables are B and H, and they're the same for both triangles. So this is true. So moving on to question 16, and we're told that 2x minus 5y equals 13. We're told that 3x plus 4y equals 8, and we're asked to solve this pair of simultaneous equations. And I'm just going to label this equation 1 and this equation 2. So the way I want to do this is I want one of these equations to just be written in terms of one variable, because then it can be solved. So what I'm going to do is I'm going to take equation 2 and I'm going to rearrange it in terms of x to give me, so 3x plus 4y equals 8. Therefore 3x equals 8 minus 4y, and therefore x equals 8 minus 4y over 3. And what I'm going to do is I'm going to substitute this value in place of x in equation 1. So if I've got equation 1 here, so I've got 2 times x, and I'm going to substitute this in. And then it's just a simple case of rearranging. So in this case, we would have 16 minus 8y over 3 minus 5y equals 13. this gives us that 16 minus 8y is equal to, over 3, is equal to 13 plus 5y. Therefore, 16 minus 8y equals 3 times 13 plus 5y, and this equals 39 plus 15y. And if we bring the 8y across, we get that 16 minus 39 equals 15y plus 8y, and therefore we have that 23y is equal to minus 23, and this means that y equals minus 1. Now that we know that y equals minus 1, so I'm just going to circle this, we're then going to substitute this into one of the equations to find out the value of x. So if I take equation 2, and equation 2 is 3x plus 4y equals 8, then I can substitute this value of y into here, and I get that 3x plus 4 times minus 1 equals 8. So I have 3x minus 4 equals 8, 3x equals 8 plus 4, which is 12, x equals 12 over 3, which equals 4. So our final solutions are that x equals 4, y equals minus 1. And if you really want, and probably advisable, would be to go and check this works for each equation. So moving on to question 17, and we're told that a solid hemisphere has a radius of x, and a solid cylinder has a radius of 3x and a height of x, and we're told to work out the ratio of the total surface area of the hemisphere to the total surface area of the cylinder. So if we start off and we have this surface area of the hemisphere, well, if we look at a hemisphere, then, I apologise for the lack of quality in the drawing, if we have this radius of x, the surface area covers both the area here, which is the area of this circle where it's been cut in half, but then we also have to consider the surface area of the sphere as well. Now it's a hemisphere, so it's going to be half the surface area of a full sphere. So if we're told that the surface area of a sphere is 4 pi r squared, then the surface area of a hemisphere is going to be 2 pi r squared. So this is equal to 2 pi r squared plus, and it's going to be this circle where it's been cut in half, which is just pi r squared. And this is equal to 3 pi r squared, and we're just going to change the notation because it's actually x, so it's 3 pi x squared. Now, moving on, and we want the surface area of a cylinder. Now, let's just consider the cylinder for a second. So, this is our cylinder. So, if we think about it, there are 3 surfaces here, and it has a radius of 3x and a height of x. So, if we break this down, we've got a circle with a radius of 3x. So, the area here is pi r squared. We have another circle on the bottom, which again has a radius of 3x, so it has an area of pi r squared. Obviously r here, sorry, I should say 3x, but we'll convert it after. And then finally, we're left with this strip around the outside. Now, if we can imagine, if we were to unfold this, we would be left with a rectangle which has a height of x, and it's going to have a length. Well, the length is just going to be the perimeter of a circle. And the perimeter of a circle is 2 pi r. So in this case, it's going to have this length here, 2 pi r. So what we need to do to work out the total surface area of the cylinder is just add all of these areas together, and what we're going to get is, if we start off with the shape here, so the rectangle, well, let's just actually fill in our values quickly. So 2 pi r, we know that that is 2 pi times 3x times x, and then plus pi r squared plus pi r squared, so which I'll just simplify it as 2 pi, then again r squared is, so r is 3x, So it's going to be 3x squared. So let's simplify this. So we're going to have 6 pi x squared plus 6, no, that's not correct, plus 2 pi times, so it's 3x all squared, which is 9x squared. So it's actually 6 pi x squared plus 18 pi x squared. So we've got 6 pi x squared plus 18 pi x squared. This is equal to 24 pi x squared. So if we now compare the two ratios, so we have the surface area of the hemisphere compared to the surface area of the cylinder, we have 3 pi x squared to 24 pi x squared. So we can ignore the pi's and the x squareds. So we have 3 to 24, and we can just divide both of these by 3, and we get 1 to 8. So they exist in the ratio 1 to 8. So moving on to question 18, and we're asked to circle the possible value of x, where x is greater, or rather I should say the cube root of x is greater than 6 and less than 7. Well, the way we want to do this is we can cube each of these values, and if we do that, we get that 6 cubed is less than x, and x is less than 7 cubed. And if we work out what this is, we get that x is greater than 216 and less than 343. So of these values, x could be 290. So moving on to question 19, and we are given a list of numbers, 2, 4, 6, 7, 9, and we want to work out how many 5-digit odd numbers can be made using these digits once each. So for it to be an odd number, it's going to have to end in a 7 or a 9. So if we just call the other 4 numbers A, B, C, and D, so we have A, B, C, D, 7, and we'll just call it A, B, C, D, 9. So this is what we're looking at here, and the other numbers don't actually matter that much, but what matters is, for the 4 numbers preceding the last digit, how many combinations can we make? So the way we work this out is to work out the number of combinations of 4 digits is going to be 4 factorial, which is 4 times 3 times 2 times 1, which is, well, 4 times 3 is 12, times 2 is 24, so it's going to be 24. But then we do this twice, once for when we have the last digit of 9, and once for when we have the last digit of 7. So the actual answer is going to be 24 times 2, which is 48. So there are 48 different 5-digit odd numbers that can be made. So moving on to question 20, and we're told that K, L, and M are weights, and we have these 2 sets of scales. So how many M weights are needed to balance 1 L weight? Well, let's just start with what we know. So we know that 3K and 4L are balanced. So we know that 3K equals 4L. This means that K is equal to 4L over 3. And we also know that K is equal to L plus 2M from the diagram on the right-hand side. So now we have K equals 4L over 3, and we have that K is equal to L plus 2M. So what we can do, if I call this 1 and this 2, is we can equate these two. So we can say that 4L over 3 equals L plus 2M. And this means that 4L equals 3L plus 2M, which is 3L plus 6M. And then if we subtract 3L from both sides, we get L equals 6M. So this tells us that for 1 L weight, we need 6 M weights. So moving on to question 21, we were told to express x squared minus 6x minus 15 in the form x minus a squared minus b. So this is just completing the square. So the way we do this is if we look at this first part of the quadratic equation, we take half of the prefix before x, so half of 6, which is 3, and we say that we can represent this x squared minus 6x as x minus 3 squared, and then I'm going to just call this outside bit plus y, and we need to work out what this plus y or minus b is as they've given it to us. So what we're saying is x minus 3 squared plus y is equivalent to x squared minus 6x minus 15. Well, what is x minus 3 squared? And you'll see the reason we do it like this. So x minus 3 squared is x squared minus 3x plus 9, which, when we simplify this, is x squared minus 6x plus 9. So the reason that we do this method where we take half of the value at the top before the x is that we need the first two parts, the x squared and the x, we need that first part to be the same. And you can see they are the same. So we have x squared minus 6x, and then it differs just on the integer value at the end. So now that we've worked this out, we've said that x minus 3 squared plus y equals x squared minus 6 minus 15. And we want to work out what this value of y is. So the way we do this is, now what we can say is x squared minus 6x plus 9, because remember x squared minus 6x plus 9 is our value of x minus 3 all squared. So let's just make that clear. And then don't forget we have this plus y term on the end equals x squared minus 6x minus 15. And now we can simply solve for y. So in this case, well, we can actually just subtract x squared from both sides. So we can cancel that out. We can subtract 6x from both sides. They cancel out. So what are we left with? We're left with 9 plus y equals minus 15. And so y is equal to minus 15 minus 9. And therefore y equals minus 24. And so if we go back to the top, we can write x squared minus 6x minus 15 as x minus 3 squared plus y, which is minus 24. Moving on to question 22, and we're told that a equals root 2 and b equals root 18. And we're going to match each expression to its value. So we're told that a squared is equal to 2. What about a plus b? Well, a plus b, when we have 2/3, is, so we have root 2 plus root 18. Now, do we have that as an answer? No. So we can simplify that. So root 2 plus, in this case, we can break down root 18 as root 2, root 3. And this becomes root 2 plus, I beg your pardon, root 2, root 9. And root 9 is just 3, so this is plus 3 root 2. And root 2 plus 3 root 2 is 4 root 2. So a plus b is 4 root 2. We have ab, so a times b. So root 2 times root 18. So in this case, well, we've already said that root 18 can be broken down as 3 root 2. So we can say that this is root 2 times 3 root 2. And if we multiply root 2 times root 2, we just get 2. So this becomes 2 times 3, which is 6. And then lastly, we have b over a, b divided by a. So again, we know that b can be expressed as 3 root 2, and then a is root 2, so we just cancel out the root 2's, and we're left with 3. Moving on to question 23, and we're told to write 0.13 reoccurring as a fraction in its simplest form. So the way we're going to go about doing this is we're going to say that 0.13 reoccurring is equal to r. And now I'm going to say that 100r is equal to 13.3 reoccurring. So 100r is just 100 times 0.13 reoccurring, so 13.3 reoccurring. And I'm going to say that 10r is equal to 1.3 reoccurring. Now what I'm going to say is 100r minus 10r is equal to 13.3 reoccurring minus 1.3 reoccurring. Well, 100r minus 10r is 90r, and 13.3 reoccurring minus 1.3 reoccurring, well, the 3 reoccurrings we can just cancel off, so it becomes 13 minus 1, which is 12, and therefore r is equal to 12 over 90. And we can simplify this one. So if we divide top and bottom by 6, you have 12 over 6, which is 2, 90 over 6, which is 15. So the answer is 2 over 15. So moving on to question 24. And we have the points P, Q, and R, and we're told that R is at coordinate 8, 22, and they form a triangle. We can see this is a right angle triangle. We're told that the line PQ is a horizontal line, and that P crosses the y-axis, and the angle PRQ is a right angle, and the gradient of PR is 2, and we want to work out the coordinates of Q. So where should we start with this? So just a bit of notation. I'm going to call the gradient M, and what I'm going to start out by doing is saying that the gradient, I'm just going to write in brackets PR, so this is the gradient of the line PR, so the line that goes from P to R, is equal, well, we know it's equal to 2, but definitionally, how do we work it out? Well, it's the y coordinate of R minus the y coordinate of P over the x coordinate of R minus the x coordinate of P, and we're told that that's equal to 2. Well, we know a few of these values. We can see that the y coordinate of R is 22, or rather we're told that. So we're told that yr equals 22. We're told that xr equals 8. And we also know that the x coordinate of P is equal to 0, or we can see that from the diagram. So we now have 3 values. So what we can say is, let's rub that out, we can say that if we go back to our NPR, that is equal to, and we're just going to plug these values in, it's equal to 22 minus the y coordinate of P over 8 minus 0, which equals 2. So if we rearrange this, so if we say that 22 minus y coordinate of P is equal to 2 times 8, which equals 16. And if we add P to both sides, we have that 22 is equal to 16 plus y of P, and then subtract 16 from both sides, and we have that y of P is equal to 6. So we now know that the coordinates of P are the x coordinate is 0, and we now know that the y coordinate is 6. And we already know that for R, the x coordinate is 8 and the y coordinate is 22. And for Q, what do we know? Well, for Q, Q lies on a straight line with P. What that means is the y coordinate of Q is going to be the same as for P. So we know that the y coordinate of P is 6, so the y coordinate of Q is going to be 6, and the x coordinate we still need to work out, so I'm just going to call that x of Q. So how are we going to go about doing this? Well, the gradient of the line RQ is equal to, and this is where knowledge of gradients come in, so if it's a right angle between the line PR and RQ, then the gradient, so the gradient of MPR is equal to minus 1 over the gradient of the line RQ, and vice versa. So the gradient of the line RQ is equal to minus 1 over the gradient of the line PR, and that's just a definition of gradients. So this means that the gradient, and in fact, let me just rub that out. So this means that the gradient of the line RQ is going to be equal to minus, and what was it? It was 2, minus 1 over 2. So that's the gradient. And then we know that this is equal to y of q minus y of r over x of q minus x of r, and that equals minus a half. And the only value we don't know here is x of q, so that's what we're going to solve for. So we know that y of q is equal to 6, so we have is equal to 6 minus 22 over x of q minus 8, and if we just simplify this one more, so 6 minus 22 is minus 16, so we have minus 16 over xq minus 8 equals minus a half. If we divide both sides by minus 1, we can just cancel out the minus sign, and then from here, if we multiply top and bottom by xq minus 8, we get that 16 equals xq minus 8 over 2, and then if we multiply both sides by 2, we get that 32 is equal to xq minus 8, and therefore xq, if we add 8 to both sides, is equal to 40. And so our final coordinates for q are equal to 46. So for question 25, we want to show that the following expression can be written as tan x, where x is an acute angle, where acute obviously means it's going to be less than 90 degrees. So the way we're going to go about this, and there are several ways. One is just to memorize the values. I'm going to show you how you can derive them quite simply, and I'm hoping this is a method probably that might not be too commonly used, but I think it's really useful. So the way we're going to do this is we're going to start by drawing an equilateral triangle. This is a triangle with all angles and sides of the same. So the same angle inside, so it's going to be each angle is 60 degrees. And we're going to call each length 2. And we don't have to specify the unit, it's just 2. And what we're going to do is we cut this in half. And I'm just going to draw this again as 2 separate triangles now. So this is a right angle. This angle is still 60 degrees. And then this angle up here is going to be 30 degrees. And then we're going to do the same on the other side. So again, we've got 30 degrees. This is a right angle, and this is going to be 60 degrees. And what we're going to do is we're going to use some rules that we know. So if you remember SOHCAHTOA, so sine of x equals, so OH, so opposite over hypotenuse, and cosine of x equals, so ka, adjacent over hypotenuse. And what we're going to do, we're just going to call this left triangle, we're just going to call this the sine triangle, and this right-hand sided triangle the cos triangle. So if we want to work out what sine of 30 is, so our angle is here, well then opposite is the angle, it is the length opposite the angle we're looking for. So this will be the opposite side, and then we know the hypotenuse will be this length here. Now, one thing I also forgot was, obviously we know the side length as well, so we know the hypotenuse on each side is 1. Nope, that's not true. We know that the hypotenuse on both sides is 2. And we also know along the bottom that the total length before was 2. So if we split it in half, each of these is going to be a length of 1. And then we can work out what the adjacent side is going to be. So sine of 30 degrees is going to be equal to opposite over hypotenuse. Well, the opposite is 1 unit and the hypotenuse is 2. So sine of 30 degrees is a half. Let's just scroll up slightly. Now cos of 30 degrees is going to be equal to adjacent over hypotenuse. Well, let me just label the sides. We know the hypotenuse is 2, but in this case, the adjacent is this side here, which we don't know. And we can work out the adjacent side using Pythagoras' theorem. So Pythagoras' theorem in this case would say, and I'll just label this opposite as well. Pythagoras' theorem would say, and I'm going to call opposite O and adjacent A, so it would say O squared plus A squared equals H squared, where H is a hypotenuse. And therefore, adjacent, which is what we're trying to work out, is going to be H squared minus O squared, and we're going to take the square root of that. So H squared is 2 squared, and then opposite is 1, so O squared is 1 squared. So this is going to be root 2 squared is 4 minus 1 squared, which is 1, so 4 minus 1, root 3. So cos of 30 degrees is going to be root 3 over 2. So we have our sine 30 degrees and our cos 30 degrees. Last step is our tan 45 degrees. Now there are many ways again to do this, but I'm just going to show you a way that I find works for me, because I sometimes forget with tan. So I think sometimes the easiest way is I draw out a sine and a cos graph. So let's just label it. So we've got our y-axis where we have a 1 and a minus 1, and then we're just going to mark 90 degrees, 180 degrees, and in fact we don't even need to go past this. This is perfectly sufficient for what I'm trying to do. So let's draw our sine graph. So let's choose to do this in red. So our sine graph at 0, it starts at 0, at 90 degrees it goes up to 1, and then at 180 degrees it comes back down to 0. And if we change colour, let's go for a nice blue. For a cos graph, we know that it starts at 1 at 0 degrees, and it comes down to 0 at 90, and then it goes to minus 1 at 180. And I'm just going to label that. So that's cosine of x, and that's sine of x. And the key thing to note here is that at 45 degrees, I'm pretty sure this isn't perfectly drawn, but at 45 degrees, sine x equals cos x. So we can see they have the same value at 45 degrees. We also know that tan of x is equal to sine of x over cosine of x. So in that case, if sine of x equals cos of x, then tan 45 degrees is going to just equal 1, because if sine of 45 equals cosine of 45, two values that are the same over each other just equal 1. So now we have all these values, we can simply plug this in to what we have. So we have 4 sine 30, so that's 4 times a half, minus tan of 45, which is 1, over 2 cos 30, so 2, and if we remember, cosine of 30 was root 3 over 2. So this equals, well, 4 times a half is 2, minus 1 is 1, over, and then the 2's here will cancel, so 1 over root 3. And then going back to our triangle, and in fact I'm just going to redraw the triangle. So if we just take this half here, where we know this is a right angle, we said this was 30 degrees and this is 60 degrees. This is the hypotenuse, and this had a length of 2, this had a length of 1, this has a length of root 3. Well, we know that tan of x equals, so soka toa is opposite over adjacent. So, and we want that to equal 1 over root 3 to express this as tan x. So we have 1 and we have root 3. So in this case, if we want the 1 to be opposite, well, the 1 is opposite 30 degrees, and this would still be adjacent. So if that was the case, then it would be tan of 30 degrees that is equal to 1 over root 3. So we can express this original expression as tan of 30 degrees. So here in question 26, we can see that we have a square within a circle. We're told that O is the origin, and we're told the circle has a circumference of 20 pi centimeters. Q is a point on the circle, and OPQR is a square. And we want to work out the value of A given that the perimeter of the square to the ratio of the circumference of the circle is root A to pi. So the first thing we're going to do here is note that the circumference of a circle is given by, and I'm just going to call this circumference, equals 2 pi r. That is the formula, where r is the radius. And we've been told that this is equal to 20 pi. So this immediately allows us to work out what the value of r is, because we have 2 pi r equals 20 pi. So we can cross out pi from both sides, and then we rearrange to get that r equals 20, oh my god, 20 over 2, which equals 10, and this is in centimetres. So the radius is 10 centimetres, which is quite useful. So this means we now know that this length here is 10 centimetres, and we can use Pythagoras' theorem of right angle triangles. So we know that this is 10 centimetres. That allows us to work out this side here. Now, obviously, we've got to remember this is a square, so these two sides have the same length. So as a reminder, Pythagoras' theorem would say that a squared plus the other side, if we were to call it b, a squared plus b squared equals r squared, where r is the radius. So in this case, instead of a squared plus b squared, it's a squared plus a squared equals r squared. So we have 2a squared equals r squared, and therefore we have a squared equals r squared over 2, and we have a equals the square root of r squared over 2, which equals the square root of 10 squared over 2, which is 100 over 2. So we know that a is root 50. And now what we want to know is the ratio compared to the circumference of the circle. So just to be clear, a is only one side. So if we want to know the perimeter of the square, then this is going to be 4 lots. So I'm going to call this peri. So peri equals 4 root 50. So therefore, peri to the ratio circumference equals 4 root 50 to 20 pi. And now we want to try and work out if we just have pi on the right hand side. So we can rewrite this as 4 root 25 root 2 equals 20 pi, and root 25 is 5, and then times that by the 4, so we have 20 root 2 equals 20 pi. Well, we can cross out the two 20s, and then we have root 2 to pi as the final ratio. So in this case, a would be 2. And last question of the day, question 27. And we're told that a journey has 2 stages, and we want to work out the average speed for the whole journey. And we're told that it should equal 2ab over a plus b. Well, the average speed, so I'll call it speed average, it's going to equal the distance total over the time total. Well, the distance total is 2 lots of 30 kilometers, so that's going to be 60 kilometers, and this is going to be over the total time. The total time is 30 over a plus 30 over b. Now, in the denominator, we can simplify this. So this is going to equal 60 over, and we can factorise. So we take out 30, and then we're left with 1 over a plus 1 over b. And now we can simplify because we have 60 over 30, which is 2, which is left on top. And now we have 1 over a plus 1 over b. Now, our next step is we want to try and get rid of this plus symbol in the bottom, and we just want to have something over something else. So the way we can do this is on the left-hand side, we can have, instead of 1 over a, if we multiply top and bottom by b, well, b over b is just 1, so it doesn't actually change the fraction, but it allows us to have ab in the denominator. So we're going to change this to b over ab plus, and on the other side we do the same thing with a. So A over AB. So you can just check these, B over AB. Well, the B's would cancel out and you just have 1 over A. And plus A over AB, well, A's would cancel out and you'd have 1 over B. So neither of the fractions have changed. But what we can now do with this is we can now write this as B plus A over AB. And just move this up. Finally, what this allows us to do is when we have something and then over something, well, then this is going to come up to the numerator. So this becomes 2AB over B plus A, which, okay, A plus B, they're the same thing. So this is what we expected to get.
So thanks for watching, guys. Hopefully you found that useful. If you have any questions or even just feedback for how this could be more helpful, leave a comment and I'll get back to you as soon as possible. If you haven't already, hit that like button and subscribe to our channel. As I said at the start, this really will help us grow, so your support is really appreciated. With that said, all the best, guys, and I'll see you at the next one.